Welcome to MetaMinds Academy. This is a lecture series on matrices. This is a fourth lecture in this series. In this video, we are going to learn the concept of elementary row operations and column operations, echelon form of a matrix, how to reduce a matrix to its echelon form. So coming to the elementary row or column operations, so here we should remember 3 points. The first point is you can interchange. You can interchange two rows or columns. You can interchange rows or columns as a part of elementary operation. You can interchange R1 and R4 or any two rows. For example, I take R1 and R2 like this. I write. This means you are going to interchange R1 and R2. The second one is you can multiply a row by a constant. This is K into R. So for example, you can take any row and you can multiply that particular row by a constant K, a scalar K. That means what? You have to multiply all the elements in the row with the constant K. Right? So that is one of the operations, row operations. And the third one is you can multiply ith row by A and I multiply jth row by B and then add or subtract. So as in the second point, you can multiply a row by a constant. Here rj by b, and the additional thing is you can add these two or you can subtract these two. Right. Next, what do you mean by echelon form of a matrix? Suppose you are given a matrix Aij, right? Some order m by n. Suppose you are given the matrix A. So when do you say that the matrix is in echelon form? If the number of zeros preceding the first non-zero entry of a row increases row by row until only 0 rows remain. Right? So for example, let us take this matrix A equal to 13504, 13504, 02, 4, minus 13, 000, 13, 00000. This is of order 4 by 5. You have 4 rows in this. If you observe, there are no zeros. What is the first non-zero entry in the first row? First row is 1. Right? So there are no zeros preceding this to the left side of 1. Okay. Next, coming to the second row, the first non-zero element entry is 2, and to the left of 2 we have 1 0. And coming to the third row, you have first non-zero element is 1, and to the left of 1, first non-zero element, right, you have 3 zeros, and this 3 number of zeros is more than 1 0. You have 3 zeros in the third row and 1 0 in the second row. So this 3 is more than 1. And if you come to the fourth row is entirely 0 row. So what the definition is saying is until 0 rows remain. Right? So till the third row you check the number of zeros preceding the first non-zero entry in the row should be increasing row by row. So this is said to be in the echelon form. Okay. The next concept is how to reduce a matrix to its echelon form. Now let us take a problem and solve. Okay. Reduce to its echelon form. So reduce this matrix to its echelon form. To reducing a matrix into echelon form, we always follow row operations only, not column operations. Okay. Now, what we have to do is, in the first row you have A11. So below A11, you make all the entries below A11 using all the entries 0 to 0, right, using A11. In the next step, You find A22 here, right? In the next step, we make these two entries 0, that means this entry and this entry, using A22. In the next step, we make this entry 0 using A33 and so on. Okay. So below AII, we make all zeros. We try to make all the entries into 0 using row operations. Below AII, A11, A22, A33 and so on. So here A11 is 1. Using this entry, we convert these three entries to zeros. So how to convert these three entries to 0? Let us write. That means we are going to make changes to R2, R3 and R4. So R2 I am going to change. Here we have 2. How to get 0 here using this one? 2 minus 2 is 0. So you need to multiply R1 by 2. So R2 minus 2R1. R2 minus 2R1. So what happens? You should not write equal to here, right? Because we are going to modify the matrix A and it will not be, it is no more the matrix A, it will be changed. So we don't name it another matrix, but we write a similarity symbol here. So that means this matrix and the matrix that we are going to obtain are similar to each other. We are not going to change the first row. So 1, 2, minus 2, 3. There is no change in the first row. In the second row, R2 minus 2R1, here 2 minus 2. So what is R2? R2 is 2, 5, minus 4, 6, minus 2R1. 2 into R1 is what? 2 into 1, 2. 2 into 2, 4. Minus 4, 6. Then you subtract, you will get 0, 1, 0, 0. So you get 0, 1, 0, 0 here. Right. Now, next thing is, we have to get 0 and 0 here also. So how to get 0 here? We add this minus 1 and 1. We have to use R1 only, remember. So we are going to make changes to R3. So it is R3 plus R1. If you add R3 and R1, you will get 0 here, right? So 0, 3 plus 2, 5, 2 plus minus 2, 0, minus 2 plus 3, 1. Okay. And then we have to get 0 here. That means R4 implies R4 minus 2R1. Just like in the first equation. You multiply this by 2 again. So 2 minus 2, 0. 4 minus 4, 0. Minus 1 minus of minus 4. Minus 1 plus 4, 3. 6 minus 6, 0. Okay. So this is the first step. So next step is we have to make entries below A22. What is A22? A22 is this now. Right. So below this we have to make zeros. This entry is already 0. So we need to convert this 5 into 0 using row operation. Okay. So how to do it? We are going to make changes to R3. So R3 is going to change like a R3 minus 5R2. We have to use this only. We have to use this entry only. Not use R1 to modify R2, R3 or R4, because if you use R1, what happens? This 1 is going to impact these three entries and make these three again non-zero. Right? So our objective is to, once we have made these three entries 0, you should not make them non-zero again. Any operation that is going to change these three zeros into non-zero is a waste operation. That we should not do. So we have to use this only. Then these two zeros will not influence the other one. So what we are going to get right here is the first row. We are not going to change 1 2 minus 2 3 0 1 0 0. We are not going to make this also. Third row we are going to change. Okay, R3 minus 5 R2. R3 minus 5 R2. So this 5 minus 5 is 0. This is already 0 and this is also 0 now. And this minus this 0. 1 minus 5 into 0 is 1. And this one, last row, you are not doing anything to this row. You write it as it is. Right. Now, this is not in echelon form. Why? Because the first non-zero entry in the second row is 1. Before that you have 1 0. But in this third row you have the first non-zero entry is 1. Before that you have 3 zeros. Okay, 3 is more than 1. But first non-zero entry in the fourth row is 3. Before that you have only 2 zeros. So third row has 3 zeros. Fourth row has only 2 zeros before the first non-zero entry. That should not be considered, right? That means it is not in the echelon form. But for that, what should we do is R3 and R4 is swapped. Then what happens? It is 1, 2, minus 2, 3, 0, 1, 0, 0. R3, R4 we have to write here in place of R3. 0, 0, 3, 0, 0, 0, 0, 1. Now if you see, here we have 1 0 in the second row, 2 zeros in the third row, 3 zeros in the fourth row. Right? And you cannot make this 1 into 0. Right? You can make this to 0 using this entry 3, this value 3. But in that process, these three numbers will impact, right? These three numbers, that means these three numbers will convert these three numbers into these three zeros into non-zero values. That is not our objective. Right? Without affecting the zeros, we should make something to be 0, and that is not possible here. Therefore, it is in the echelon form. That is the end of lecture 4 on matrices. Please subscribe to my channel if you have not subscribed yet. Please like this video, share this video with your friends and classmates, and also give your valuable feedback in the comment section. Thank you so much. We'll meet in the next video.